All right, let's dive into one of the coolest, most powerful ideas in all of artificial intelligence, reinforcement learning. At its heart, it's really all about teaching a machine to learn the way you and I do, through plain old trial and error. It's not about memorizing a rule book, it's about discovering for yourself how to win. I mean, just stop and think about that for a second. What if a machine could learn not from some giant pre-made data set, but just by doing, by trying stuff, seeing what works, what doesn't, and piecing together the rules of its world completely on its own? That's the incredible idea we're going to unpack today. So let's kick things off with Section 1, Learning by Doing. To really get a handle on this, we're going to take this huge kind of abstract idea and bring it right down to earth with something I think we can all relate to. Just picture it. You've fired up a brand new video game for the very first time. There's no tutorial, no instruction booklet, nothing. It's just you, a controller, and this totally new world to figure out. So what do? Well, your goal, your whole mission, is to figure out the best way to succeed. You're trying to find all the secrets, master all the moves, and learn which monsters are bad news and which ones might drop some loot. You're trying to find the absolute optimal path to victory just by playing the game. And that right there, that video game scenario, is the perfect metaphor for reinforcement learning. Let's look at this official definition. It's a paradigm of algorithms. That's just a fancy way of saying it's a specific method for teaching machines. They learn optimal behaviors, that's our learning to win part, through trial and error in dynamic worlds. And that dynamic world, that's our video game. It's basically a system for an AI to learn the best moves to make based on nothing but pure experience. Okay, so that's the what, which brings us right to Section 2, the core learning loop. Now we're going to get into the how. How does this actually work? Yeah, this is the big question, isn't it? Back in that game with zero instructions, how does the player, or the AI, have any clue what to do? How does it figure out that, say, jumping on a mushroom gives you a power-up, but running into a spiky shell is, a very bad idea? Well, it all comes down to this really elegant, simple loop. First, the agent takes an action. It decides to jump. Second, it sees the outcome. Hey, it landed on a platform and a coin popped out. Third, it gets a reward, a little positive nudge, like plus 10 points. And finally, the most important part, it learns and it repeats. That little point boost reinforces the idea that jumping there was good. Now, just imagine that simple loop running millions, even billions of times. That's how an AI doesn't just learn a game, it completely masters it. But, it's not always quite that straightforward. And that leads us to this really fascinating puzzle right at the heart of RL. Section 3, the explorer's dilemma. This quote absolutely nails the single biggest challenge. Every single learning system, whether it's a person or an advanced AI, is constantly fighting this battle between exploring new things and exploiting what already works. Let's go back to our game. To exploit is to just stick to the first path you found that gets you a pretty good score. It's safe, it's reliable. But to explore, that's to have that little voice in your head that says, I wonder what's behind that weird-looking waterfall. Maybe there's a huge treasure. You have to risk the points you know you can get for the possibility of getting something way better. And striking that perfect balance between sticking to the script and trying something new, that is probably the hardest problem in all of reinforcement learning. Okay, let's zoom out a bit. Section 4, RL's place in AI. Where did this powerful idea even come from, and why is it so important for the bigger picture of artificial intelligence? So reinforcement learning didn't just pop up out of nowhere. It's really standing on the shoulders of some serious mathematical giants. It's built on ideas from dynamic programming, which is a method for solving massive problems by just breaking them into tiny, solvable pieces, kind of like figuring out the best way through a single room in a dungeon before you tackle the whole thing. It's also tied to optimal control theory. That's the super complex math you'd use to steer a rocket to Mars by making constant, tiny, perfect adjustments. These big ideas helped forge RL into what it is today. And that's really why it's such a game changer. You can see reinforcement learning as this massive milestone in the story of AI. It represents the shift from machines that could only follow instructions we gave them to machines that can actually discover strategies that are novel, creative, and sometimes way beyond what a human could come up with. It's become an absolute pillar of modern AI. And that leads us right to our final section, where we get into the really deep, mind-bending questions that are still out there. Section 5, the limits of learning. So after this whole journey, from a simple video game to the foundations of modern AI,
we're left with this absolutely massive question. When a machine is just learning from its own experience, exploring a universe of its own making, are there fundamental limits to what it can figure out? Are there truths or strategies that are just forever beyond its reach? This is the grand challenge that keeps pushing the whole field forward, and it's a pretty wild thought to end on.